Hello everybody, welcome back. I think it's time to get going here. So I sent an email this morning telling you about sort of my plans for the week. Take off my jacket. I'm serious now. My plans are, Friday is the next test, and the test will cover just the stuff that we've had since the previous exam. So we also have a regular homework assignment due this week. So today I'm going to do extra examples that are just on the material for this week, which is only two sections, the initial value problems and substitution. And then tomorrow I'm going to send out the review sheet for the test and do examples on all the sections for the test. All right, I hope that sounds all right to everybody. Are there any questions at this point, vaguely about the test? I mean, I think you know what to expect by now. As always, the test will not be cumulative, so it'll cover only the new stuff, although there's, some old stuff you will have to still know about, the product rule, the quotient rule, that kind of stuff, but there won't be specific sections or questions for it. All right? All right, let's just get into the examples then. So I want to do, we've only got two sections, right? There's the initial value problems and the substitution. In my opinion, the substitution is quite a bit harder, but I figured we'd do two problems from each section. Initial value, so let's start with the initial value problems, which are easier in my opinion. I'm just going to choose two problems out of the book. The first one is number 46. This is section 7.1, in case you care. Number 46. Do the initial value problem. It says, so the problem is, it says c prime of x equals, what is it, 0.2x squared plus 5x. And then it says the fixed cost is $10. All right. And your job in this case, so the question is, the words of the question says, this is a marginal cost function, and your job is to find an equation for the cost. So we are going to find c of x, an equation for the cost. So in this problem, we are given the derivative c prime, and our job is to figure out what the original function is, c. All right. Of course, what we're doing is the antiderivative, right? If somebody tells you the derivative and you're asked to find the original function, what you do to do that is you find the antiderivative. How do we interpret the fixed cost? The fixed cost means like the cost of making no things. In the real world, when you're making things, you got to pay a certain amount per thing that you make. But actually, you also have to pay just like to build the machines or whatever, set up your operation. Even if you don't make any things, just to prepare to make things, you have to spend some money. There's a cost to that. So the fixed cost here, this should be interpreted as c of 0 equals 10, right? That's what the fixed cost means. Even if you make no stuff, the cost of making no things still has a cost to it. In this case, it's 10. Anyway, let's do it. So c of x will be the antiderivative of the, well, let me just write it this way, right? That's what the antiderivative means. You take something which is already a derivative and it gives you the original function. Okay, we are given the c prime in this example, so it's 0.2x squared plus 5x dx. And we just do the integral. This is not a hard integral. I get 0.2 as a coefficient, and then 1/3 x squared plus 5 is a coefficient here, and then 1/3 x cubed, sorry. 1/3 x cubed there, and then 5 times 1/2 x squared. And then, as always, we do our plus c. Now, in the previous sections, the plus c didn't matter, and I just said you always got to put it there. Actually, in this section, the plus c does matter. This right here is an equation for c of x, which was our job to find c of x, but it has this extra unknown constant, the plus c. What is the plus c? In a problem like this, you can actually solve for the c using this fact right here. The cost of 0 equals 10, so I'm going to plug in x equals 0, and C of 0 equals 10. So the left side becomes 10. If I'm using 0, the left side will become C of 0, which is 10. And then when I'm using x equals 0 on the right side, what happens? Well, I get 0.2 times 1/3 times 0 cubed plus 5 times 1/2 times 0 squared plus C. And ordinarily, you might have to use your calculator to solve for C in a formula like this, although in this case, these are all zeros, right? 0.2 times 1/3 times 0 cubed, that's 0. That's also 0. It just says C equals 10. And so my final answer is what I said before right here, only C is 10. So I can write the full formula for C of x without using any unknown constants. And it is C of x equals 0.2 times 1/3 x cubed. I'm just writing the same thing again, but using the fact that C equals 10 means I can put 10 on the end there, not an unknown variable C. All right, this is how we do it. As usual, you could simplify things a little bit here. If you want, you can multiply 0.2 divided by 3. I don't care about that. Any questions about that one? This is how we do a simple initial value problem. All right. Okay, let's do one that's a little less simple. So the next one I want to do is a longer word problem, and in preparation for that, I took a little picture of it. Put it right there. How do you like that? This is high tech. This picture comes from my book, which has the answers in it. So the words in blue there at the end there, those are the answers. Hopefully we get it right. It says the marginal profit in dollars on Brie cheese sold at a cheese store is this formula. I assume this is a made-up formula, where X is the amount of cheese sold in hundreds of pounds. And it says the profit is minus 40 when no cheese is sold. So, all right. Part A, find the profit. So you notice that what we're given is P prime of X. They told us the derivative of P. Our job is to find the function P. All right, let's do it. We do it in the same way as before. I'm going to do, P of X is the integral of P prime of X, the antiderivative. And the function they told us, X times 50x squared plus 30x dx, and we have to do this antiderivative using whatever tricks or whatever methods we've already learned how to do. Anybody have a suggestion? How do I do this antiderivative? Someone want to shout out a suggestion? I like shout outs.
Distribute the x.
Distribute the x. Thank you for the shout out. Yeah, distribute the x here. Notice this right there is a multiplication, and you cannot just do the antiderivative of things which are multiplied. You have to somehow deal with the multiplication first. And what we can do in this example is distribute. Another way you deal with multiplication sometimes is by doing the substitution, which is in the next section. But in this example, don't try to do the substitution. Distribute. What do we get? We get x times 50x squared becomes 50x cubed plus x times 30x becomes 30x squared dx. And then we can do the antiderivative. Now we don't have to do anything special. This becomes 50, the coefficient, 1/4 x to the 4, plus 30, this is the coefficient here, 1/3 x cubed, and then plus c. So this is the antiderivative. And this is almost the answer, although, like before, we need to figure out what the c is. So this is p of x, right, is this. All right, maybe I look at the answer there. Does it look like I'm doing this right? I got 50 times 1/4. Look at the answer up here. It says 25 over 2. That's the same as 50 times a fourth. They just combine the fractions. And then I got 30 times 1/3 here, which is the same as the 10. Now they have minus 40. Apparently that's going to be the answer when I solve for the c. But let's get there when we get there. In order to solve for the c, you use the initial value, which is given in the original problem. It says the profit is minus 40 when no cheese is sold. No cheese would, x is the amount of cheese, so no cheese would mean x is 0. So what that means is basically p of 0 equals negative 40. That's what this statement here is. Yeah, I'm writing in the book. The profit is negative 40. That means P of 0, the profit of no cheese, is minus 40. Okay, we conclude like we did before, plugging in. So I'm going to plug x equals 0, and P of 0 is minus 40, right? So on the left side, I get minus 40. On the right side, I get whatever this stuff with 0 plugged in. 1/4 times 0 to the 4 plus 30 times 1/3 times 0 to the 3 plus c. And again, these things being 0 on the right side, these are going to go away entirely, and I just get c is negative 40. And so indeed, I do get what they said in the book, the answer. This is 50 times 1/4 x to the 4. If you like, you can simplify that to 25 over 2. I don't care. Plus 30 times 1/3. That's equal to 10. I don't care. Minus 40, right? I just replaced the c with the 40. So this is my final answer. That's the answer for part A, right? There was a part A and a part B. Any questions so far about this? This is my answer for part A. All right, so that was part A. Part B, let's go back to the question here. Find the profit from selling 200 pounds of brie cheese. All right. 200 pounds. Now the units in this problem, it says, here's a little thing to notice. X is the amount of cheese in hundreds of pounds. So when this says 200 pounds, this means x equals 2, right? Don't try to use x equals 200 here. X equals 2. The profit from selling 200 pounds. The units are hundreds of pounds. So what part B is asking is very simple. There's no derivatives or antiderivatives involved. It's just find the profit when x equals 2. And I have a formula for the profit already. So part B, we're going to find P of 2. And I mean P, the profit, not P prime, which was given in the original problem, but P, which I just solved for in part A. So all you got to do is plug in 2 for x to your answer from part A. So it's 50 times 1/4 times 2 to the 4th plus 30 times 1/3 times 2 cubed minus 40. And this you can put into your calculator. And what do you get? You get you get the right answer. Would you mind if I just, rather than typing that into my calculator, I look at the blue number? 240 is what you should get. Do you trust me that that really is 240? I don't know if you should trust me, but I don't want to do it in my calculator. All right. Any questions about that? I see this on your homework sometimes, by the way. People get some weird answer, and then they write down the answer that they found in the back of the book rather than simplifying themselves. That's fine as long as you did it right in the first place. I will look carefully and notice if you messed it up and tried to fool me by writing the correct answer at the end. All right. Any thoughts about that one? Okay. Let's try some from the other section concerning substitution, integration by substitution. So this is a major trick. And it's really the only trick that we're going to talk about as far as finding the antiderivative of more complicated functions. There are other tricks. If you go on to take Applied Calc 2, you will learn some other tricks. There's one that's based on the product rule called the integration by parts. The substitution trick is based on the chain rule, and it's based on choosing something to be like the inside of a function and something to be like the outside of a function. I hope you watch the video because this isn't going to make a lot of sense. Like you have to live with this for a while to understand how it's done and understand why it works. But I wanted to do 2 examples. The first is an easier one. The second is a harder one. And then we can talk about whatever you guys want to talk about. All right. This is the first one, which I claim is an easier one. You should, when you look at one of these, you should first ask yourself, do I need to do the substitution? Like on this homework, you have to do the substitution every time. That's the point of these homework problems. But for instance, on the test on Friday, I'm not necessarily going to tell you to use the substitution or not. And it will be up to you to decide, look at it and decide what trick, what do I have to do here? Well, one thing you should notice immediately is there is a multiplication right there. Right here is multiplication. That means you better do something here. You can't just take the antiderivative of each thing. And you have this exponent here, and you better handle that somehow. So you should not, absolutely not just take the antiderivative here and then also just take the antiderivative here. That will give you the wrong answer. How do you handle multiplication and exponents? Well, the other way to handle multiplication is just to distribute, but you can't distribute here because of this exponent. You might think, well, when I have an exponent, I could sometimes like multiply it out, do the FOIL or something. But here the exponent is 20. There's no way you're going to do the FOIL 20 times, right? So none of that's going to work. This will suggest to you, I guess I probably have to do the substitution because none of my simple tricks will work. So when you try to do the substitution, you must identify the u. You choose the u, and the strategy is you choose the u to be the inside of something, the inside of parentheses, or maybe the inside of an exponent, or maybe the inside of a denominator, the inside of a square root sign, something like that. All right. There's no hard and fast rule when you do the substitution. You just have to try and hope that it works. So, but in this case, I think it's fairly clear. What should I choose to be the inside of something? Anybody want to say? What are you going to choose the u to be here?
X cubed plus 4.
Yeah, I'm going to choose x cubed plus 4 because it's the inside of those parentheses. All right. Next step when you're doing the substitution is to find the du, and the du is the derivative of u. So that's easy to do. The derivative of u, derivative of x cubed, is 3x squared. The derivative of plus 4 is 0, so that is going to go away when I do the derivative. And then I always include dx as part of the du. All right. This can be a little confusing. The du is the derivative, even though the larger problem here is to find the antiderivative of something. When you're doing substitution, you have to use the derivative inside there. It's true, this can be confusing. You just got to keep it straight. I'm back. I had to turn on, I have a little heater because it's cold down here in my basement. What next? Okay, we have chosen the u and the du. Now we should try to do the substitution. The substitution involves rewriting this thing, simplify the stuff inside here so that it's all in terms of u rather than x. So the first thing I would like to do towards that end, I'm going to do this in a few steps. I'll leave the x squared like it is for now. I'm going to replace x cubed plus 4 with u because that was the whole purpose of this substitution, was to make that thing equal to the u. And now this becomes u to the power 20 because it was, you know, that stuff to the power 20. That stuff is u, so now it's u to the power 20. All right, the u to the 20 I like. So when I look at this here, I like this guy. I don't really like this guy. I like the u to the power 20. Remember, my goal at this point is to change everything into u's, and u to the 20 is in u's. The x I don't like. What I'm going to do is just rewrite this to gather the u stuff at the beginning times whatever is left over, which in this case is x squared times dx. That's the leftover stuff, which I still have to figure out how to rewrite in terms of u's or du's. This leftover stuff generally will be written in terms of the du's. What is x squared dx? Do you see this up here? Actually, I do see that. It is most of the du, right? It's not equal to du. It's 3 times that is equal to du. We can solve for that by dividing the 3. So I'm going to write it this way. 1/3 du equals x squared dx. You divide the constant over to the other side. And now I can plug in inside my integral there, where it says x squared dx, I can replace that with 1/3 du. So this is now integral u to the 20 times 1/3 du. All right. There's still multiplication in there, but it's only a constant. And as we have discussed, you can move a constant out of the integral. So this is the last step of the substitution. That whole thing is 1/3 times u to the 20 du. All right. Now this, I wrote this out in many steps. Once you get used to it, you can do a lot of this in your head, and you don't have to write down every little step if you don't want to. 1/3 times integral of u to the 20. Any questions so far? We're not done yet, but this is the hard part, which I've done. The hard part is rewrite the whole integral so that it uses u's only and no x's. All right. Next step is to actually do the integral. I saw when I was grading the homeworks, I saw some people don't like to write the integral sign. They just, I don't know, you're too cool to write the integral sign. You better write the integral sign or you're going to get very confused when you're doing the u substitution. In the next step, I actually do the integral. The 1/3 stays out there. And then the integral of u to the 20 is 1 over 21, u to the 21 plus c. All right. I did not write the integral sign anymore. That's because this is the step at which I did the integral. So you should have written the integral sign on all the previous steps because you had not done the integral yet. You were just rearranging the inside. That step right there, I actually did the integral. And then, so this is just about the final answer. The only remaining thing is we are supposed to write our final answer in terms of x just because the original problem was in terms of x. So the last step is to replace the u with whatever it is in terms of x. So it's 1/3, 1 over 21, and then instead of u, I'm going to write the x's again. X cubed plus 4 to the power 21 plus c. And that is the answer. What do you think? Any thoughts about that? Any questions about that? This is the u substitution. It's a little tricky in my opinion.
So I guess my question is, what happened to the du?
What happened to the du? This is a good question. You will notice from this step here, I had an integral sign and a du, and they both, I didn't write the integral sign again, and I didn't write the du again. This is because the integral sign and the du together represent the antiderivative. So if you recall, in an ordinary integral, something like the integral of, how about 8x squared dx? The answer is 8 times 1/3 x cubed plus c. And nobody asked me last time, what happened to the dx? The answer is, I did the integral, so I don't write the integral sign anymore, and I also don't write the dx anymore, because when you do the integral, those things go away because you did them. So you should think generally like the dx is kind of like part of the integral sign. The integral sign and the dx together represent the fact that you're taking the antiderivative. And that's why in an example like this, after you do the integral sign goes away and also the du goes away. I hope that made sense.
Okay, thank you.
Any other, what are your other questions? All right, I got one more of these substitutions just for fun. Let's try integral of 5x e to the 3x squared dx. All right. Again, your first thing when you look at this, you should think about, do I even need the substitution at all? You do in this case because I see two sort of giveaways that a substitution is necessary. First of all, there's multiplication right here, and there's no way, sometimes with multiplication we can distribute it, but there's nothing to distribute here. So this multiplication is definitely a problem, and you need to do the substitution to handle that. Also, we have a weird thing inside the exponent. There are no, we have rules for doing exponential functions, but none of those rules involved x squared inside the exponent. They were always either just x or a constant times x, but x squared inside the exponent, we got problems. So we need to do the substitution. Remember the procedure here. We choose the u. You choose the u yourself, and then the du, you calculate the du by taking the derivative. What do you think? What should I choose for the u?
3x squared.
3x squared, they said. Yeah, I agree. You want to choose the inside of something, inside of parentheses, inside of exponent, inside of a square root sign, something like that. In this case, I think the only reasonable choice would be 3x squared. And then the du is the derivative of u, which is 6x dx. Remember, dx always is included in du. All right. Okay, let's see if we can plug everything in. So I'm going to start trying to replace things with u's. 5x has to just be like it is. I'll begin by just putting u where it is, right? 3x squared is u, so I put e to the u instead of e to the 3x squared. Okay, and then what remains to be substituted is the 5x and the dx. So maybe I will gather those together like I did before. 5x dx. And now, how am I supposed to handle... Actually, I don't mind the 5 so much. The 5 is a constant which can be removed from the integral. Maybe I'll... Would you mind if I do that, actually? There's no sense in carrying the 5 around on the inside, because a constant multiple can always be pulled all the way out of the integral. Then we don't have to worry about the 5 at all. It'll just sit in front of our final answer. Anyway, what do I do with x dx? I see x dx right here, and I can isolate it by dividing 6. So this will say 1/6 du equals x dx. This little step of dividing the constant is almost always necessary. So if you find yourself dividing this constant every time, that's kind of what happens. Sometimes you get lucky and the constant already matches exactly what you want, but usually you have to divide the constant to the other side. Okay, 5 integral e to the u, and then x dx. So I have this 5 here, integral e to the u. X dx is times 1/6 du. All right, the substitution is complete. We have removed all the x's and replaced them by u's. I have this 1/6 on the inside, but that can be factored out of the integral. So it's going to be the 5 is already out there. The 1/6 I bring out also. It ends up being 5/6 integral e to the u du. All right. And now we do the integral. Does anybody recall what is the integral of e to the u? You got to remember your formulas about integrals of, you know, really what I'm asking is this integral. Come on now. And remember this one. Integral e to the x is?
E to the x.
E to the x, yeah. Plus c, of course. So what is the integral of e to the u? It is e to the u plus c. So this becomes 5/6 e to the u plus c. Right? Now, it looks like what I did in that step was just erase the integral sign. That's not, I mean, on the paper that is what happened, but really what I did was I did the integral, and I just happened to get the same thing as what I had before, all right? When you do the integral of e to the u, the answer is e to the u. So that's why the integral sign and the du went away. I did the integral e to the u, I get e to the u as the answer, and then I put plus c because I just did the integral. And finally, the last step is always easy. You plug the x's back in. So my final answer is 5/6 e to the power 3x squared plus c. And that right there is how we do it. This is the substitution. Any questions about that example? These are a little tricky, like I said. You got to just kind of do a bunch of them, get used to it. One thing I would like to say about this is, after you do the substitution, if you have some time left over on the test when you're doing this or something, it might be a good idea to check your answer, check yourself before you wreck yourself, as they say. How can I check my answer? This is the antiderivative of that, right? So if I'm correct, then when I take the derivative of that, the answer, the derivative of this should equal this. Let's see if we can make that happen. So I'm going to check. I'll do it in blue. Check it. I take the derivative of the answer, the derivative of 5/6 e to the 3x squared plus c, right? What is that? If I did everything correctly, I should get the original thing that I started with as the answer for the derivative. What do I do here? First of all, when I take the derivative, this is added together. So I'm just going to do the derivative of the first part and then also the derivative of the c. But the c being a constant, this will go away. So the plus c will become 0 when I take the derivative. What about this e thing? It's going to require the chain rule. I have a coefficient 5/6 will stay like it is. And then the derivative of e to the 3x squared is the same thing again. This is the derivative of e to the x times derivative of the inside of the exponent will be 6x. All right. And then, like I say, plus c will become plus 0 because the derivative of the c is 0. And then that is the derivative. You could simplify if you want to. The 6's will cancel here, and then if I just move the x out front, it says 5x e to the 3x squared. And that, my friends, is actually what I started with at the very beginning inside the integral. So this is correct. The fact that this is equal to that is what means I definitely did it right. All right. So if you're doing this on a test, you might want to take, if you have the extra minutes, take a moment, check yourself. All right.